Well, guys, today's video is going to be a little different because I messed up on the recording, and so I don't have students. I'm just going to go through the whole lesson, and I'll kind of let you know when we paused in class, but we're not going to do any pauses because I'm going to go basically straight through the whole thing. So today our big focus is on interpreting remainders in solutions. One of the keys on this is the only way I can really interpret remainders is if I have context. And in math, the way we give you context is we make it word problems, because just having numbers doesn't give you context for interpreting what the remainders mean. So the downside, that means a lot of today's work is going to be in word problems. Sometimes you can ignore the remainder, sometimes the remainder is the answer, and sometimes you're going to go above the answer. So the remainder is going to tell you you're going to have to go up. And we'll talk about all three of those situations today. Our first problem, we have the Red Cross Disaster Relief Fund. They collect 3,551 winter coats to distribute to flood victims. There are 23 distribution centers. How many coats can go to each center? There's our question. Marla calculated it. She did some beautiful calculations over here. You can see she came up with her mathematical answer of 154 and 9 23rds. So she says that the Red Cross can send 154 and 9 23rds coats to each center. Madison says you can't have a fraction of a coat, so each center will receive 154 coats. There will be 9 coats left over. Who's correct? So here's where the tables discussed it. When we came back in, almost everybody got it today, partially because they really gave you the answer right here. You can't have a fraction of a coat. So Madison is correct. So even though mathematically it works out to exactly what Marla said, 154 and 9 23rds coats, Madison's correct because I can't cut the coat up. I can't have pieces of a coat. It's not going to be very efficient. You're much better having 9 left over. One of the earlier classes, they mentioned, well, that would allow you to send 9 more to one of the bigger centers. You could divide up those 9 however you wanted to. Normally, you'd send 1 to each of 9 different centers. Because I can't have pieces of a coat. So I got distracted on what I was saying. So that one's really the big one. On our side note, and here's kind of where we got back at the start, 2 pieces. I can round down when I don't need to use the remainder. Should be working. There we go. And round up when you need the next whole number larger than your answer. In some cases, you're going to go ahead and use the remainder, which is kind of our third possibility. Sometimes the answer is with the remainder. You may use the remainder. One big key on that. Oh, just a sec. Okay, so our next part, we're going to use this one word problem and do several problems off of this. So the Carnegie Mellon School is hosting a picnic for any 5th grader who will be attending school next year as a 6th grader. The hospitality committee is planning for 125 students. Each 5th grader will get a sandwich, a drink, and a dessert. So there's 3 parts. Let me just stress again, especially when we're talking about word problems, marking your text is so critically important, guys. It's going to help you understand what you need to do, especially as we start getting into the questions. So the hospitality committee is ordering large sandwiches that each serve 8 people. If 125 5th graders are coming to the picnic, how many sandwiches should the committee buy? That is our question. So you have to make sure when you're done that you have answered that. So at this point, I gave everybody in class a chance to work on this and the entire next page because they're all built off of this. But since we're now just doing the video, let's just go ahead and work this out. So working it out, it's really not too difficult. I take the 125 students, I'm dividing it 8 ways, so because each sandwich will serve 8 people. It's going to go once into 12, subtract 8 gets me to 4, bring down to 5. It's going to go 5 times into 45, gives me 40, so I have 5 left over. So I can write that as 15 and 5/8. So that's exactly how many I need, but the sandwich shop is not going to sell us 5/8 of a sandwich. So this is where this piece comes in. So you got to think about it. Do I drop the remainder? Do I round up? Or can I use it? In this case, I can't use remainder because I can't buy 5/8 of a sandwich. If I round down, then I'm not going to have enough sandwiches. So in that case, I'm going to have to round up. So they need 16 sandwiches. Make sure that we are doing full sentence answers on our word problems. And that should be easy. Okay, our next page. Committee is planning to have frozen fruit bars. If they come in boxes of 12, how many boxes should they order? So we take our 125. Now we're dividing it by 12. So it's going to go once into 112. Bring down the 5. And here's another critical one. It's not going to go into 5. So I have to put that 0 there to mark my place. Now you have two options. I could go into decimals or I could go into fractions. Since they didn't give us decimals or fractions in my problem, I get my option. I'll be honest with you guys, if I have the option, I'm going to stay with fractions because it makes it easy. This is my numerator, and my divisor is my denominator. So it becomes 10 and 5/12. So again, I ask myself the question, can I get 5/12 of a box? No, they're not going to allow you individual sale. They're actually marked on the boxes in the commissary if you ever go there. It'll actually say not labeled for individual or retail sale or individual sale. Meaning 10 boxes won't be enough, so I need to get 11 boxes. So they need 11 boxes. That's our answer there. Next one, they're planning on serving bottles of water. Bottled water comes in cases of 24. How many cases of water will they need? Will they have any extra bottles of water? If so, how many? So there's actually like 3 parts to this question that we need to make sure we're answering all of them to get a complete answer on this one. So I still have the same 125, dividing it by 24. So because these numbers are easy, I'm not going to do a whole factors table. But we can see 24 is going to go into 125 5 times. That's going to be 120. It leaves me 5 left over. So I need 5 and 5/24. Meaning, again, 5/24, I can't buy parts of a case. So I'm going to have to go up. So they need 6 cases. Of water. The next part, will they have any extra water? Yes. If so, how much? So they will have, and here's where it can get a little confusing, but so far today everybody seems to have gotten it. My remainder was 5. That means I need 5 bottles out of that next case. My cases are out of 24, so I do the math. 24 minus 5, they're going to have 19 left over. So we answered both parts. We could have said yes, they will have 19 left over, or answer that, but they have 19 left over does answer that they have extras. Okay, the 5th graders are going to take a bus from the elementary to the middle school in the afternoon. If each bus seats 32 passengers, how many buses will they need to transport the students? How many seats will be empty? So again, we have 2 parts to this question. We need to make sure that we answer both of them. So we start again with our basic math. We've got 125. This time, though, we're dividing it by 32. So that's going to go only 3 times. Gives us 96. Doing that math, 15, it gives us a 9. 11 minus 9 gives us a 2. So, excuse me. 3 and 29/32 buses are needed. I can't get 29/32 of a bus. I need a whole one, meaning I need to round this answer up. So they will need 4 buses. Additionally, how many students are empty, or how many seats, not students? I need 29 more seats. There's 32 possible, so that means there will be 3 empty seats. So if they plan it out well, they can put 1 empty seat on each bus, give them, spread them out a little bit, or they can pack 3 of them like sardines, and then just put the 4th one with the empty seats. Our next one, throughout the year, local businesses collected 28,654 pairs of eyeglasses for disaster. They have requests from 236 relief organizations. how many pairs can each organization receive? How many pairs, if any, will be left over? So again, we have two parts to our question. Now, initially, if I see a number like 28,654 divided by 236, I know that there are a lot of students that I've got that are going to look at that and say, oh my gosh, that's too hard. I am not even going to try. Honestly, guys, if you'll do the multiples table, it makes this whole thing far easier. You should be able to knock it out really quickly. Because again, your multiples table, all you're doing is drawing your table with 9 slots so that I can write all of the factors, all the multiples, 7, 8, and 9. And all I'm doing is adding 236 to itself. So I just go 6 plus 6 is 12. 6 plus 1 is 7. Bring down the 2 and 2 is 4. 6 and 2 is 8. 3 and 7, 10. 6, 7. 14, carry the 1, 4, 9, 10, 7, 8, 11, 6, 11, 3 plus 1 is 4, 6 is 12, 3, 4, 5, 6, bring down the 1, 8, 8, 8, 1, 14, 11, 12, 10, 11. So now that I've got the factors table, it makes it super easy. So I just start going through it. Won't go into 2, won't go into 28. Goes into 286 once. 236 gets me a 5. Bring down the 5, 505. Looking at my table, it's going to go twice without going over. So I'm going to subtract 472. Gets me 3, 3. Then bring down the 4. Again, I'm back to 1 on that one. So 236 gets me 8, 9. So I have 121 and 98, 236. So breaking that down means that each center is going to get 121 pairs. Of glasses, and there will be 98 left over. So there's my 2 answers to my 2 questions. As you can see, in this case, you may not have needed the factor table because 1, 2, and 1, those are all rolled pretty easy, but it didn't take us long to build that factor table or multiples table, and you can see that it can be extremely beneficial, especially if I'd been required to go into the decimal places. Okay, our next page. This one, I'll be honest with you guys, I don't really like this very much. You're not going to see this on a test. Ms. McShannon and I are not going to do that to you, but for some of you, it may visually help you understand what all is happening. So consider the quotient, 3 and 57/100 divided by 3/10. If I use 100 grids, because I'm looking at hundreds places here, it could help us understand what's happening. So the combined shading represents 3 and 57/100. If I add all 3 of the colors together, you can see that's 1 hole, 2 hole, 3 hole, and then this one is the 57/100. So you can divide into 3 equal groups. So if I go through it just number by number, if I take the 3 and divide it into 3 equal groups, it means each color gets 1 whole group. Then going to the 10th place, 5, it's going to go in once, so each one gets a whole 10th by itself. You can see those there. And then that's going to leave 2 left over from the 5, so that means you get 27/100. So 3 divided into 27/100, that's going to go 9/10 of a time. So that's where this extra 9/10 comes out. And if you count them up, 2 and 7, that gives us 9, 1 and 8 gives us 9, and then that one had 9. So in all, each group ends up with 3 and 19/100. So you can see it from the shading. Again, we're not going to make you do that. Here's the key. We want you to be able to do this. So my divisor is on the outside, my dividend on the inside. It doesn't matter if my dividend has a decimal. when I'm doing the division, the decimal just is going to come straight up into the answer or quotient. So I just say, how many times will 3 go into 3? Once. Subtract the 3, got 0. Bring my decimal into the quotient. Then I look at the next number. I bring the 5 down. 3 goes into 5 once. That number goes here. Subtract the 3, gives me 2. The 7 comes down. 3 goes into 27 9 times. Subtract 27, I get to 0, and I know that I'm done. So my answer is 1 in 1900ths, which is what our model also showed us. So this one I didn't actually go over in class, but since I've got extra time, let's just talk about it real quick. If I compare the two worked examples, describe how the hundredths grid model represents different parts of the standard algorithm. We did that as I went through. The wholes were the 3 divided by 3. And then the portions were the 57 hundredths divided by 3, or 19 hundredths for each color. Why does the standard algorithm show subtracting 3 from the 3 ones in the dividend? Because I need to work through the problem place by place. So place value is extremely important in fraction division or decimal division. And we'll see a couple examples of that as we finish up the lesson. But by taking away the 3 from the 3 holes, it showed me that those 3 holes were not taken care of. What does the 05 represent in the standard algorithm? I'm thinking that is let me take a look back. Oh, the 05. So that was our remainder with what was brought down. So that's the part they're talking about in the standard algorithm there. So this was the 10th place in the standard algorithm. Okay, what does the 27 minus 27 represent? And this is the hundredths place. Because I ended up with 2 left out of the 10th place right there in the 5 hundredths place. And that gave me 27 for the hundredths. So remember, if you multiply both the dividend and divisor by the same number, the quotient remains unchanged. So 12 divided by 3 is 4. If I multiply them both by 10, that would be 120 divided by 30 would still give me 4. If I multiply them both by 100, now I'm talking 1,200 divided by 300. The answer is still 4. Okay? So the quotient remains the same because you are dividing by a form of 1. And this one, all we're saying is because I'm keeping the same factors, all I'm doing is changing and adding a 0 to both numbers. I'm still dividing by the same thing. Why is this one important? It comes into our next piece. Because just as we did with fractions, we cannot divide fractions by fractions. We instead multiplied by the reciprocal. Decimals is slightly different than that. I still can't divide by a decimal. It just doesn't mathematically make sense. So instead, what we're going to do is change our divisor to make it into a whole number. The way we do that is, fortunately, we're working with decimals. Decimals all work on a base 10 number system, which is how our number system has been developed. So because it's base 10, it means that for every decimal place in my divisor, I can just move my decimal once by multiplying by 10. But if I multiply the divisor by 10, I also need to multiply the dividend by 10. So whatever I do to the divisor, I do to the dividend. So let's talk about how this works. So if I have a standard setup in a mathematical problem, the mathematical terms for the two pieces are dividend and divisor. The dividend in this case is 7 and 56 hundredths. My divisor is 3 and 6/10. I don't care about decimals and dividends. They don't affect the math at all. I do care about decimals and divisors. Why? Because 3 and 6/10 times 2 is 7 and 2/10. But to actually take that away when we're doing long division, you can't take 7 and 2/10 from 5. My remainder works out really funky. So instead, what we're going to do is focus on making sure that our divisor is a whole number. So that's really our key. Make the divisor a whole number. So once we've done that, it's going to make the math a lot simpler. How do I do it? Really simple. I just count the number of decimal places in my divisor, in this case 1, and I'm going to multiply by a power of 10 for every decimal place. So if it's 1 decimal, it's multiplied by 10. 2, I multiply by 100. 4, I multiply by 1,000. Make sense? Or 4, I'd multiply by 10,000. I need 4 zeros. So that should be relatively easy. Again, the key though, once I've done the divisor by a number, I must do the dividend by that same number. So in this case, I multiply them both by 10, and instead of 7 and 56 hundredths, what I'm going to actually divide is 75 and 6/10 divided by 36. Again, I don't care about a decimal in my dividend, because all that's going to do is the decimal comes straight up into my quotient. As long as my divisor is a whole number, I'm good. So on this one, I just say 36 goes into 75 twice. That's 72. Subtract the 72 leaves me 3. Bring down the 6. But remember, as I bring that down, my decimal must go up into my quotient. The decimal goes straight up from the dividend to the quotient. So 36 minus 36, that's going to go once. So then I get to 0. So my answer is 2 and 1/10. Should make it relatively simple. So to rewrite a problem so the divisor is a whole number is really simple. Again, I look at the divisor, I say 1 decimal place, I'm going to multiply them both by 10, so I get 480 divided by 86. Again, I focus on the divisor. I have 2 decimal places, so I'm going to multiply it by 100. I have to do the same to my the dividend. One big key, when I multiply by 100, if I have blank spaces, they get a 0. So this becomes 5,950 divided by 17. Again, focus on the divisor. I have 2 decimal places, multiply by 100. So I'm moving it twice. Blank spots get a 0. 620 divided by 2. Makes it really easy. Just as a side note, if I just rewrite these as a long division problem, this would be 48 divided by 8 and 6/10. Instead of doing it out here, I could just do it here. But if I move it once here, I must move it once on the inside. Again, blank buckets get a 0. And I do the same thing on all the rest. So 59 and 5/10 divided by 17 hundredths. I need to move it twice, so I move this one twice. Blank buckets get a 0. 6 and 2/10 divided by 2 hundredths. Move this one twice, move this one twice. Buckets get a 0. Super easy, guys. Now, just to see that this doesn't make a difference, here's an example. If I have 7 divided by 56, it's going to go 8 times. Subtract 56, I get 0. If I go 70 into 560, I kind of use that same process. 7 goes into 56 8 times. 8 times 70 is 560. Gets me 0. Adding 2 zeros doesn't make a difference. 7 goes into 56 8 times. Multiplying that, 700 times 8 gives us 5,600. 7,000 is still going to be 8 because 8 times 7,000 is 56,000. So if I have the same number of zeros in each problem, no zeros, I get the same answer. So multiplying by factors of 10 doesn't change your answer. So how are the divisors and dividends in the last 2 problems related to the first problem? They are all increased by the same factor of 10. What I mean by that is this one I multiplied the divisor by 10 and the dividend by 10. Divisor by 100, dividend by 100. Divisor by 1,000, dividend by 1,000. Okay? Calculate all four quotients. What do you notice? They're the same. What happens to the quotient when you multiply the dividend and divisor by the same number? The quotient stays the same. And that will always be the case, guys. And it doesn't, I don't know if I should say this, it doesn't have to be 10, but the 10s is what makes it easy. But as long as I'm multiplying both by the same number, then my quotient will always stay the same. Okay, last page. Which of the division expressions have the same quotient as 475 divided by 25? Key here is understanding where our decimals are. So I need 3 and 2. Also, another definition. The definition of division is A divided over B equals A over B. Therefore, you can use what you already know about equivalent fractions to determine which expressions have the same quotient. In other words, as long as they're all lined up the same, have the same number of decimals, they're going to be the same. I'll be honest, guys, the easy way to do this is just look at my divisor, figure out how to get it to 25. So I move it twice, meaning I move this one twice, that one's the same. It's 475 divided by 25. Move this one 3 times, move this 3 times, end up with 2 zeros. That's a different one, so that one doesn't work. Move this one twice, move this one twice, that's 47 5/10. That one doesn't work. Move this one 4 times, move this one 1, 2, 3, 4. Now I've got 475 and 25. That one is the same. So we ended up with 2 that were the same. Calculate each quotient. This one, really simple. You've got 2 choices. Again, focus on your divisor. I can either do the multiplication on this side, or I can set it up in the division problem, in long division, and just move it here. So I can move it here, or I can move it here, or if you really want, you can do both. But because I know I've got 2 decimal places, I'm multiplying this by 100, multiply this by 100, gives us 7,440 divided by 12, or if I just move it, you'll notice empty bucket means I need to add a 0. That's where 7,440 comes from. I'll be honest, you guys should know your factors of 12 up to 12, so I'm not going to do a separate multiples table. If you don't, please do a multiples table for it to make your math easier. But 12 is going to go into 74 6 times. That's going to give us 72. Gives us a 2, bring down the 4. That's going to go twice. Subtract 24 gives us a 0. This is a really key point, and one that I'm seeing a lot of students miss. My decimal isn't till here, so this place still matters. I have to realize 12 goes into 0 times, so that has to go there. It's only once I get to my decimal that my points, that I know the problem is over. So this one equals 620. We can do the same thing on our last one. I can either multiply here, again, focusing on the divisor. So I'm going to just move it once, moving this one once because I multiplied it by 10. So I'd have 66 and 2200ths divided by 2 and 2/10. I'm moving it once, so it goes over to here. These numbers are easy, so I'm not going to do a separate multiples table. If they were more difficult, I would. But I can just see from looking at them that this is going to work out easily, because 22 is going to go into 66 3 times. Gives us a 0. I bring down the 2. Here is a critical piece, though, because 22 won't go into 2. I have to have that 0 up there. Okay? So I didn't subtract anything. Now it's going to be 22. Now it comes down to 0. So my answer is 301. So that's today's lesson. Again, math work, homework is just Mathio. You're doing the next 4 workstations. It's exploring decimal facts, patterns with products and quotients, multiplying decimals, and decimal products. Let's go back to that page so you guys can see them. There they are. So those are the 4 that you're doing. We're not going to be too stressed. You don't have to have this done by next class period. We won't be checking it but at that point, but you are going to need to get done eventually. So please utilize your seminar time wisely and make sure you're getting this stuff done. Come see us if you have any questions. Good luck, guys.